good morning, good afternoon, or good evening, depending on your time zone. Welcome back to the spring webinar program. As always, I'm your MC, Peter Humphrey. I am fortunate enough to be joined today by two of my longtime colleagues, Mark Pollack and Sabby Anandan, who I will let introduce themselves. They're going to talk to us a little bit about cloud native patterns for data-intensive applications and some of the latest improvements in Spring Cloud Dataflow 1.6. Mark and Sabby, would you like to introduce yourselves?
Yep. Hi, everyone. Thanks for taking the time today. I'm Mark, and I am the project lead for Spring Cloud Dataflow.
All right. Hi, my name is Sabby Anandan. I am the product manager for Spring Cloud Dataflow in the ecosystem, which includes Spring Cloud Stream, Spring Cloud Task, and others. Okay, I guess we are ready to go. I am going to start skipping the slide to get this started. So for agenda today, of course, the title for this webinar is Cloud Native Patterns for Data-Intensive Applications. And I thought it would be good to open it up describing what data-intensive application means. And then dovetail that into Spring Cloud Dataflow, what we do and how we provide some of the toolkits and patterns to solve for some of the challenges that you as a developer foresee while developing those applications. And then we wanted to bring in some patterns that we see in the industry and also in the at the customers and community on how this all comes together while orchestrating onto cloud platforms. We want to share some of our findings and trends. And towards the end, we want to open it up with some use cases that we also see in the field, and hopefully also dovetail that into Q&A and have you all ask some questions. So with that said, I'm going to open it up with the general industry trend, at least the types of use cases, the types of trends that we see at the customer base. I want to open it up as a level setting. So you all probably might have heard the digital transformation is really a hype thing in the industry right now. Fundamentally, or ultimately, it all gets down to how customers who are building software and data-centric products, how quickly and frequently they want to deliver value to their customers. And how with these types of models, and DevOps plays a really critical role transitioning the data-centric business into more modern and more cloud-native type of architectures and businesses overall. And while doing this types of re-architecture, we also see in the industry that there's a lot of event-driven practices and architectures are evolving, and that's on the rise, and data is at core of it. And there's also a pattern emerging where which we hear a lot of chatter in the community about batches going away, ETL is going away, but we we acknowledge that at the same time we see a lot of customers still having a lot of ETL workload, and the way how these ETL workloads evolve and develop and orchestrated onto platforms are changing, and we see that trend and acknowledge that as well. And the last one that I have on the slide is about machine learning, right? So if you are into digital transformation journey, you obviously are reacting to all your customer inputs and wanting to provide products and services that are more meaningful for them. And machine learning helps with that. And we see a lot of developer community are catching up to that trend and wanting to embrace new toolings and practices to make that type of more proactive recommendations to more proactive products and services that they can deliver to their customers. So we see an upswing in that trend too. So switching the gear a little bit, so going back to what we mean by designing data-intensive applications, so the great book from Martin Kleppman, he talks about data-intensive application more eloquently, saying that an application that's data-intensive, if data is its primary challenge, the quantity of data, you think about the complexity of data and the way it's changing and evolving over the period of time, they all go back into this data-intensive aspect of this application, which is a real challenge. So I want to open it up with this one slide. It's actually a video slide. I'm going to try and see if this is going to work. There's actually, it's not moving, but the idea is this video, like a short video showing all these vehicles moving. This is me once I was staying in this high-rise hotel. I was staring out from the window, and then I noticed all these patterns, and it made me compare and contrast with the data, the journey that happens within the enterprise. I noticed a lot of vehicles moving in varying speed. The vehicles are of different shapes and sizes. There's vehicles of different colors, right? And then it made me realize a similar thing happens within the enterprise too. We see you probably have data from different systems. You have database, you have file systems, you probably have event-driven systems you want to consume and do some meaningful thing with that data. Then you have data from different types, right? I mean, you have binary data to file data. You have really structured and unstructured data sets. I want to consume them all in a consistent way, and then do again some downstream meaningful processing with them. Then we also notice this data is of varying speed and shape and size, right? I mean, some are real time. It's happening like several million per second. Some are like really slow. It probably needs to happen like once or twice a day. And there's a size that's varying and different as well. And we see the general, the phenomenon where which the data structure that you probably have as a payload today, so which includes 10 fields, and tomorrow it might be 12 or 20, or you might remove some fields. Again, you are like evolving as in how the customer requirements change, and you want to evolve and adapt to it, and you want to be able to like build these types of applications for evolutionary architectures as well. So with all that put in perspective, I want to open it up with Dataflow in terms of what we do, how we solve for these challenges, how we make it more accessible for developers. So we call Dataflow a toolkit, and it helps you build data integration, real-time streaming, and batch processing pipelines. I'm going to break this down a little bit here. So fundamentally, a data pipeline, if you want to think about a definition, it's nothing but a series of steps that you want to do in terms of consuming the data and do some interesting things with that data. Whether it's real-time streaming or batch processing, it's made of several steps. In Spring Cloud Dataflow, architecture-wise, our foundation is built on top of Spring Boot, and we have Spring Cloud Stream as a framework that helps you build this event-driven streaming apps. And for batch pipelines, we provide a framework called Spring Cloud Task that helps you build this shard-driven microservices. So this is really unique for Spring Cloud Dataflow and compared with other streaming and batch products out there. So our model fundamentally builds on top of this microservices, and the pipeline is made of these microservices. So you have this benefit of independently interacting with these apps, scaling and rolling, upgrading, and things like that. We'll get into the details about these frameworks in a minute. And also from general value proposition perspective, we are trying to solve data integration challenge too. And building upon these two frameworks I just described, we have like over 60 applications, streaming and batch applications that we provide as utility apps. So you can quickly get them downloaded and get them started and build these pipelines made of these applications more rapidly. And likewise, from the toolkit's perspective, Dataflow provides a variety of client tooling. We have a DSL, which stands for domain-specific language. We have a drag-and-drop GUI, and also REST APIs. So you can programmatically build these data pipelines and orchestrate them onto cloud platforms like Kubernetes and Cloud Foundry. And as part of the toolkit, going back to the digital transformation and the DevOps practice, all that, we wanted to provide native integration. It's now why RESTful apps alone should be continuously delivered. Why can't data-centric apps be continuously delivered? So we got a lot of feedback around that. So we have a native integration of continuous delivery primitives within Dataflow that helps you upgrade and roll back all these individual apps within the pipeline. And the last one that I want to highlight is we still see the trend of ETL and the batch processing from our customers. A lot of them have that, and there's a lot of business reasons for that type of architecture. And we provide a native integration of scheduler. So these batch data pipelines can be scheduled for a recurring cadence. So you can automate that aspect of it from Dataflow too. So these are some top-level highlights here. And in this webinar, we are going to make sure to cover all of these features with more meaningful demos and walk through a solution end-to-end. So that way, these things you can reason through and resonate through more easily. So with that said, I'm going to hand over back to Mark so he can speak to the frameworks and other details of these frameworks provide. Back to you, Mark.
Okay, thank you. So as Sabby mentioned, the foundation of which the architecture relies upon are independent applications that communicate with each other. In the case of web apps, just as a foundation, you're used to seeing microservices that have web endpoints, and you might be using Spring MVC or WebFlux to create those. But the boot applications we're talking about are either long-lived streaming applications or batch applications. And both of these are also Spring Boot, based on Spring Boot. For Spring Cloud Stream, it's a very nice programming model, very simple, by which you can either use imperative style or functional style in terms of your coding. And it comes with primitives that basically allow you to easily scale up and make sure that features such as partitioning work well, and that the idea of consumer groups, which came originally from Kafka but can be applied to other middleware, allows different sets of applications to consume the same messages. So we achieve this by having a message bus abstraction. We have several implementations, which we'll show in a minute, and that means you can use sort of the middleware that you might already have in your enterprise instead of something that's unique to an integration platform. Spring Cloud Task. These are for applications that basically are batch applications, right? They start up, they do a little work, and they go away. And we keep track of the history, when it was executed, the exit status, and things like that. And one of the common themes that we'll talk about a little bit more is that because these are all applications, boot applications in particular, your expertise that you have in either the development side or the operation side of managing these applications. Typically, we talk about RESTful applications, but the same set of tools can be applied to the streaming and batch applications. So there's a chance to sort of consolidate, your best practices, how you go about testing, by having Spring Boot as the common denominator. So I'll just talk a little bit about the runtime abstraction. Where can you run these boot apps? As is expected, you can run a boot app everywhere, but what Dataflow does is it actually pushes the apps to the platform and pushes a primitive you're used to hearing about in Cloud Foundry, but we can deploy the apps to other runtimes as well. One of the most important is just your local machine, right? You want to do development, and you can iterate much quicker if you're doing it on your local box versus any cloud platform, really. Just the time it takes to start up a JVM, for example, is very small. So the two main ones that we support are Kubernetes and Cloud Foundry. We used to support more, but these are the ones that became particularly sticky in Dataflow from the feedback from the community. And so what I'll do now is I'll give a little quick tour of Spring Cloud Dataflow, the basic component, and then show you how we can address the use case of doing file ingest, which is a very, very common use case, and I think you'll see that we handle it quite elegantly. I'm going to share my screen right now. Okay. See that go. Okay. Let me minimize this, actually. So there's a UI for Spring Cloud Dataflow, and we have these primitives such as apps that you can register. These are stream apps or tasks. What's running, you can create streams, and we have the idea of tasks, and then Spring Batch Jobs, which is a special case of tasks. On the command line, there's a server, which I started up over here. You can see the little boot banner. And maybe what's important to note for this demo is I've set a property here called maximum concurrent tasks. And what this means is the Dataflow server will only launch a maximum of 5 tasks. So you might have downloaded, in our case, for example, 30 files, but you don't want to start up 30 processes all at once to do the batch jobs to process those files, because you could potentially overwhelm the resources on your cloud. I mean, compute isn't infinite in the sense of you could have tens of thousands of small files, and you're not going to have tens of thousands of CPUs or containers. So that's an important little thing. So there's a server-side component, this server. And then there's a shell. Just exit here. Again, just a a command line interface. And here we have lots of commands related to streams and tasks. Right now I don't have any apps registered, so I'm going to register a few that I have listed here. Register apps. So app list. So I have a source, which is a source of data. I have a sink. In this case, it's Task Launcher, which relates to launching a task that comes from the FTP source. And then here I have a task, which is going to convert a file and load it into a database. So the way I can hook these things together is to create a stream. I'm just going to load that up to avoid the typing. So there's a stream create command. This is it. I'm calling it FTP ingest. And now we have a DSL, which is basically a Unix-style pipes and filter model where the commands are apps, and the pipes represent the middleware, how they communicate. These can be backed by Rabbit, MQ, or Kafka. In this case, I'm using Rabbit, but it's really not that important for the purposes of this demo. So the FTP source is configured. Here I'm doing this all on the local machine. This is the port. The username and password is sort of meaningless. And the remote directory where I'm going to dump files is here. It's on my local machine, but it's effectively mimicking a remote FTP site. So FTP source dir. So if I take a look at the directory, that's empty. And when I download them, I'm going to put them into this directory, downloads. Just take a look at that. Right, that's empty as well. And what I like to do is, after it's downloaded, I would like to tell it to run this task to process that file. And so when this is done downloading, it's going to send a message, and it's going to be received by this task launcher. And what's interesting about this task launcher is it communicates with the server and says, are you ready to launch a task? And if the answer is yes, because the number of concurrent tasks is less than or equal to 5, it'll launch a batch job to process that. In person to file, I didn't have it here, but it's a Spring Batch application. I don't know if my development environment is probably a bit of a mess. Let me see if I can bring it up real quick. Should be in my recent history. Open recent. Here we go. So the files are, if you look at data files, I have had a name. You see all these people, right? And then I just basically split this up into a bunch of files. Oops. So each one's a person. And basically what's going to happen is we're going to parse this file. Here it is. You have an item writer and an item reader. This is all Spring Batch related. And the processor really doesn't do much at all. But if you were doing some ETL, this is where the interesting work would happen before inserting it into the database. So basically, we're going to take all these files and drop them into the database. So with that said, let me start this up. So I'm going to do stream deploy. Give it a name, FTP ingest. So this is starting up processes on my local machine. It's being deployed at the moment. I could do JPS, and you'll see there's a jar file that's running for the FTP source, and here's the task launcher, and it's been deployed successfully. So now what I'll do let me just minimize this guy, is I will copy the data files into the source directory. So now they're available. So basically this FTP source is polling. Here it's polling pretty frequently at the moment to see if there are new files available. If there are, it's going to download them and then try to launch all these tasks to process them. So I copy it. And now I'm going to go to this endpoint here, which is keeping track of the current executing tasks. Basically, maximum is 5, currently running is 0. So if you look at downloads, you'll see a bunch of them have copied over. And hopefully this should start executing. There we go. 1, 2, 3. So originally it polls every 30 seconds, and then you can see it gets going. If I go to the, oh, that's weird, user interface, and go to refresh this screen, tasks, you see I have 11 executions, and I think it's going to go up to 28. So basically there's a bunch of them in flight right now. And if I pop into the database and do refresh, I will now have a people table. And I can read that into the console. And there's all the data right there. So there's more rows that get loaded on demand in this database browser. Oops. So that's still chugging along. I guess we can just let it play out. At 23. And then here, you can dive into each one and find out more information about what occurred. So ingest job parameters for launching it and the step. These are particular details about Spring Batch. Okay, so that's done. This thing should be at 0 now. So processed all of those files into the database. So that's it. It's pretty simple in a way. You can see we just have a very small stream definition, and all the hard work is really being done by these out-of-the-box applications to coordinate this. Just go back to the slides for a moment. So the next one I'll show is how we can schedule batch jobs. And what we've done here is on each platform, Kubernetes and Cloud Foundry, we integrate with the scheduler that's available on that platform. So in the case of Cloud Foundry, there is a scheduler that's available as a service. So here I have logged into a CF environment. And if I look at the services in my area, I have one called Scheduler for PCF. Not too much to set here, but it's the standard plan.
Mark, you may want to share your screen.
Oh, yeah. Whoops. Keep forgetting. All right. Sorry, let me go back. Thanks, Sabby. Yeah, so I'll just repeat that. So I'm here in a CF environment. I'm running a Dataflow server here as well. And there are services. There's one called Scheduler for PCF. So that's how we interact with it through a user interface. For example, I can go here, and there are little buttons for scheduling a task, deleting a task. Timestamp is a simple app we have. Just prints timestamp and then exits. It's like the hello world of tasks. So here I can just schedule this by clicking Schedule, give it a name. And before I do that, actually, because I've done it multiple times, so you see, I've done it 13 times already. So if I go back here and schedule it, we'll see 13 increase once this gets going. So I give it the cron expression, and sort of the interest of demo, I'll make it go once a minute, which is the finest granularity you can have. So there's a schedule. We have one. And If you go back to the apps, timestamp is the app. You can look at the logs, and eventually this thing is going to start once a minute has passed, which hopefully will be soon.
Folks, if you have questions, please enter them into the questions accordion in your user interface, and we will address them at the end. We'll be keeping an eye out for whatever you might need to know.
Okay, it should be a minute, I hope. No. Sorry, guys and gals.
No problem.
All right, there it goes. So a minute has passed. It ran. It printed out its timestamp, and I refresh this. You see, it's 14. And if you'll see from when I did it in the past, I don't know if I could zoom in. You know, it occurs every minute. You see, 29, 30, 31. So I'm not going to take any more of our time waiting for time to pass, but it's just going to keep doing that all day long. And then I could delete the schedule if I want. There we go. It's all deleted. So that are the two demos I'm going to do. Sabby's going to take it a bit further, and I will stop sharing.
All right, cool. Thank you, Mark.
All right, take it away, Sabby. Thank you.
All right, sounds good. Thanks. Here we go. So yeah, so far we saw a lot of batch, right? I mean, we saw the FTP file ingest and how do you schedule those types of batch jobs in cloud platforms like Cloud Foundry. But I'm going to switch gear a little bit and talk about streaming use cases. Hopefully also show some demos on this progress, right? The first one I want to talk about is, Mark alluded to Spring Cloud Stream. There's a pluggable aspect to the framework. So we have a binder abstraction, and that binder abstraction sort of building upon that abstraction, we have implementations for a variety of message brokers. So RabbitMQ, Kafka, Google PubSub, Azure Event Hubs, or Kinesis, or even Solus, right? I mean, they're all like as an option that's available for developers. So it's at the end of the day, developers write the business logic, how this application consumes data, processes data, and leave the infrastructure and the boilerplate stuff in terms of how this application needs to connect to Kafka or RabbitMQ, right? So that is the simplification or the value proposition from Spring Cloud Stream as the project itself. And the opportunities, again, building upon the same trend. So the same code, same test, you just drop and replace just by swapping out a dependency in your POM or Gradle file, you will write and receive data from a variety of different brokers. So to continue on this, I want to show a quick demonstration of how someone can build stateful streaming workloads in Dataflow. I'm going to talk about a use case which imagine you have a social graph or social network kind of an application that you're building, and your analyst team is interested in finding out what are the top 5 states where the new users are being registered or activated, and then do that in a more 30-second tumbling window. So how do we build that type of application? And the pipeline looks similar, something like what I'm showing in this slide. I have a user producer, which is going to generate users. I'll show the code momentarily. And then on top, it goes to a consumer, and then a bunch of other events are being aggregated and pushed downstream. Think of like more CQRs or event streaming and event sourcing type of use cases building upon those user-produced events. But the demo that I'm going to show is this 30-second tumbling window. We are going to do a group by operation on user by region and publish the aggregated outcome onto WebSocket. And there is a single-page application that feeds on it, so you can visually see where the users are being registered right now. So I'm going to share my screen to show this demo in action. So let's see. Okay, like Mark, I'm going to use the local server for this first demo. I have this application already running. It's just a Java-jar, what Mark already showed. And likewise, he also demonstrated the shell application, what it does. And these are all the out-of-the-box applications that we have, which are mentioned as these utility apps. I'm going to use a few of them, but I also have a couple of custom apps, user producer and user by region app that I talked about. So I'm going to quickly pull up my IDE and show what that application does. So let's first review what user producer does. So user producer is a simple boot application. It's a Spring Cloud Stream app. It's a source application. This is the annotation that automates that, saying, hey, I'm a producer. I'm going to produce some data. I'm using this annotation to trigger this function every half a second. I'm going to create a new user with random UUID. And I'm simulating as if the user is created and sleeping for some time, activating it, and again sleep for some time, change the name. You can imagine these types of in real world. People are doing that in social network applications, right? So the idea is to produce these and publish these events to downstream topics, so we can do some interesting things with it. So it's literally this is all this application is doing. And then I have the consumer app, which is where the meat of all this the demonstration is. And this application is using a custom interface with multiple channels defined in it. So I have 2 input and multiple output channels. So this application can read from 2 inputs and publish the outcome to several downstream topics. So that's what it means. So go back to this application here. And here I have 2 stream listener handlers. And Spring Cloud Stream, this is the other value proposition that we provide. You can directly consume from channels and the events directly and do some downstream processing like how I'm showing here. Or you can directly also consume the events as K-stream objects. So now you are in full control of your business logic. You would use the Kafka Streams API, build this idiomatic, more functional style workflow, which I'm interested in finding out, filter by user-created domain event, and I'm interested in grouping by each user's region on a 30-second tumbling window. The window size is 30,000 millisecond. And that's the window that I'm going to compute this aggregate and finally return the computed aggregate as part of another K-stream response that goes downstream to that WebSocket sync. So these are the two applications. I already have that registered in Dataflow, and I'm going to build this pipeline real quick. So for that, I'm going to bring up the dashboard. We already saw some of the features of the dashboard, so I'm going to create a new stream. And this is the drag and drop GUI. So I'm saying user producer and user by region and literally pipe it to WebSocket. So these are 3 different boot applications, right? And they are all Spring Cloud Stream apps. I'm creating the stream definition, calling it foo. And the other value that we provide in Dataflow from the UI is now I can deploy these applications with several overrides. I can change the memory, CPU, disk, and other things. Likewise, I can also override properties for each of those applications. Some of the things that you can do from shell or the UI as well. But I'm going to use the freeform text, and I'm interested in specifically overriding the topic names for each of those applications. So the application properties look like this. So for user producer, I'm saying where the data needs to go to. For user by region, which is the second application, I'm going to consume data from the same topic where the producer is producing to, and the computed outcome is going to a different topic downstream, and finally the WebSocket sync is consuming from that topic. So it's literally boot properties. I'm just overriding, telling these applications where to consume and produce data to. So I'm deploying this. While it's deploying locally, as I go to this, I have these 3 applications deploying, and I also have Kafka running locally. I'm using the Kafka binder implementation in these applications. So let's see, as soon as these applications deploy successfully, so it looks like the producer is deployed and the user by region is deployed, and lastly, the WebSocket is in the process of coming together. As soon as that's deployed, I'll pull up the single page application. Okay, so all the 3 applications are deployed. My stream is in fully deployed state right now. I'm going to pull that single page application and show the results. So here, this application is showing the US map, and these are the top 5 states. If you look at the bottom of this window here in the browser console, I get these events or the aggregated count from each of the region via WebSocket, and this application is feeding on it. Now, intentionally, I put more biased users on California, so you see the color changing and the counting remaining more real time. So what we really saw in this demo is how quickly someone can build these types of use cases and produce more meaningful analytics or do some more real-time aggregates to compute some different outcomes and downstream from it, how you consume and produce all these types of services to your customers. So you can imagine the type of use case can be built with this. So that's the the end of stateful stream processing use case. I'm going to switch back to the slide and move forward to the next one that we have is the cloud-native patterns, and specifically for data-centric workloads. What does all this mean? So to learn more about it, I'm going to hand over back to Mark. So Mark, take it away.
Yep, thanks. So Sabby and myself just showed like two specific use cases, but we really just sort of wanted to drive home, what differentiates this approach from other approaches. And what you see here on the right-hand side are the graphics and text taken from the sort of seminal article on microservices from Martin Fowler, where normally you had your, let's say, ETL process, right? These blobs, all living inside one app, right? And that would often be, in the case of integration, an ESB or an application server. And now the idea is that you can break that out, right, into individual applications, microservices. And now, for example, you have cool knobs, for example, like the L part, right, loading. You can scale up the loading if necessary, because often writing into a database or writing into HDFS could be the bottleneck in your ETL transformation. So instead of having to scale up a giant monolith, you can scale up just the parts that are important. And what's also not really commonly emphasized, but noted, I guess, in the original article that Martin Fowler wrote, is that these processes communicate using lightweight communication, sort of smart apps, dumb pipes metaphor. And that doesn't have to be HTTP. It could be messaging middleware, in particular, as long as the middleware isn't really doing any sort of extra stuff beyond being a, quote, dumb pipe or reliable delivery. And what this means is this shift, right, is there's no external runtime anymore. It's basically just apps. So things around governance or deployment, they're all handled as you would deploy an app on these platforms. And there's a rich set of capabilities that each platform has for handling this. We'll talk a little bit more about those cases in a minute. So not everything can be solved by this approach. There's still a role, for example, to use Spark or Hadoop, which is a runtime, right? And you have to write for that runtime. But there's a lot of use cases, and we'll enumerate many of them, where this approach works just fine. And what's great about this is you can really leverage the existing knowledge you have of these runtime platforms and use whatever your favorite ecosystem tools are, and bring over really probably things that you've been doing more for web apps, but also for batch and integration workloads. So as an example of these sort of features you sort of piggyback on of the platform is reliability. The first version of what we were trying to achieve with Dataflow was a project called Spring XD, and we wrote our own platform, basically. We kept track of which processes were running, and if they weren't running, we started them up. And over time, we realized that this was basically building a platform. There are other similar approaches back in the day then, but now we don't have to worry about that, right? We shift the responsibility of making sure long-lived applications stay up and running to the actual platform itself. Similar, we don't have to write our own scheduler. We can integrate with the features of a scheduler on a platform. So scalability, Kubernetes, Cloud Foundry, they all have mechanisms by which you can scale either manually or have rules set up that are based on throughput, including messaging, queue size, depth, to scale up and down your apps. So again, you're leveraging sort of the platform features here instead of it being something that's unique to one dedicated data infrastructure runtime. Maintainability, this is this common denominator, right? These are all boot apps, so you can write JUnit tests for these. When you're thinking about doing stuff around continuous integration, again, whatever your Jenkins, Bamboo, whatever your tool set is, they slip right in naturally. And same thing for how you might want to approach continuous deployment, which will be a part that Sabby demos in a moment. And last but not least, portability. Spring has always been about portability, and the fact that these are apps that you could run literally on your own local machine if you type Java -jar. You can shift them anywhere there's a JVM. So that's a big benefit. So we do demonstrations all the time with these apps, and we deploy them to Kubernetes, deploy them to Cloud Foundry, and if there's a new platform in 5 years, I'm sure we'll be able to deploy it there as well. So that's a big sort of point, because your cheese gets moved all the time, so it's good to have portability in mind. So I will now hand it back to Sabby, who's going to do a last very cool demo around continuous deployment of these apps.
All right, very cool. Let's do this. So yeah, we talked about all this cloud-native patterns that we see in the field and community and customers. Certainly, we invested heavily based on feedback in terms of providing CI/CD as a native toolkit for data-centric apps. So I'm going to take a minute quickly walk through my demo setup. There's a lot of moving parts here. So I'm going to share my screen first and get this going. All right, here we go. Okay. So for this demo, I guess we saw a demonstration of local server, and Mark showed the demonstration of Cloud Foundry. But I'm going to use Kubernetes this time. So Dataflow has a Helm chart, so you provision all the software requirements for Dataflow, and I already have that, all of them running. And to speed things a bit, I already also deployed a stream definition, and that stream definition looks something like this. I have this bar XFMR. It includes an HTTP source, and it goes to a processor by the name XFMR, short form for transformer, I guess. And then lastly, it goes to the transformed output goes to a log sync, which basically logs what the transformed outcome is. So this stream is already running, and you can already see these three pods. I'm going to expand this a little bit here so we can pay attention to it. So these are the three pods representing those three applications running natively in Kubernetes. Again, I can think of these benefits running these apps as native workload. You can take advantage of all the platform-specific capabilities, right? And the other thing I want to quickly show is the stream history command. So this is something that we recently added, again, in terms of building this native CD ability, continuous delivery model in Dataflow. So now we keep track of stream versions in terms of what happened to the stream, when was it last installed, and things like that. Right now, I have only one version. And I want to quickly also show the manifest command sort of feeds into this metadata management that we have for doing some intelligent diffing in terms of what changed and what we need to compute and what we need to rolling upgrade, so without impacting your upstream or downstream nodes in the data pipeline. So I have three apps. So I have this processor, which is at 0.07 version, HTTP it has 131, and the last app is a log sync, which is at 131 as well. So let's see how this application is running. So I'm tailing the log for my log sync, and I have this simple script, and the script is like simulating as if some random security numbers are being generated. And it's going to hit the HTTP source endpoint and post that security number as the payload, and that's really all the script is doing, right? So I'm gonna start that script. So it's starting to post that data. So data is hitting the HTTP source, and from that it's going to the transformer. So I sent the data as just a number, but in the right window, as you can see the number is now transformed in the sense it's attaching this prefix, the security number equals that, right? It's every 1 second I'm posting that data. It's doing its thing happily. It's going, the data is going across these three apps, and it's backed by RabbitMQ in this case, all running in Kubernetes. Then now imagine a business scenario which we notice, oh crap, this is a secure number. I need to mask that, and it's really critical for my business, and I want to fix that. Hot fix that. How would I do that? I mean, doing this type of fix for payload that's happening more frequently, like million messages per second, how would we do that, right? I mean, how can we think of guarantees and ordering of all this payload? So that's where Spring Cloud Dataflow and Spring Cloud Skipper projects come together to provide that ability. So I'm gonna show what this application does, and I'm gonna quickly fix that and then show all this in practice, how it can be done for data-intensive applications. So I have this simple application. This is my processor, and this is simply adding that prefix, as I mentioned. It has the unit test and the integration test. I'm going to like obviously make the test fail first. So let's do that. So let's say I'm going to mask the first 5 digits, run the test, and make the test fail, right? I mean, just like doing some test-driven development in practice. So that test failed, and likewise, I'm gonna mask the integration test. The difference between the unit level and integration in this case is we provide a framework in Spring Cloud Stream that helps you post data onto a channel and consume back from a channel, so you actually are simulating as if it could potentially be bound to a topic, and you're getting data back from a topic. So that's a framework we provide in Spring Cloud Stream. And I have both the tests failing, and so let's fix the business logic. So I'm going to cheat a bit and copy paste this little code just to speed things up here. So instead of simply returning the message, I'm going to use the regex to mask the first 5 digits, right? So basically that's really the change. I'm going to go back to my unit test and run to make sure that the code is golden and it's back in green. So that's my unit test and my integration test. So let's make sure that works as well. Almost there, and that's back in green. So now, as we would do in fixing, and this is good, and I'm really trusting my fix. I'm going to bump the version. I'm going to go back to my. So while this is happening, the application is still performing. Still, the data is being processed and going across the pipeline, right? While that is happening, I'm going to like push a code, right? Push the code to my repo. I can type. So as you can see, I bumped the version and the business logic change and the unit level test and the integration level test. That's all in there. Let's add that. I'm going to do the worst git commit here, and then it's going to say mask payload. And I'm doing git push. So that's now pushed, and I have a CI pipeline managed by Concourse in this case. It's actually monitoring that repo. I'm going to speed up the polling by checking that pipeline. Concourse pipeline. So as soon as the poll kicks in, CI pipeline is going to do its thing, right? It could be Jenkins, or it could be any of your CI tooling that you have in your company, in your project. So it's building that application. It's going to run the unit test. Obviously, the version that we bumped is 008, and we know that 007 is what's running in production now. And this fix is including that masked payload version, so it's actually being built. It takes about a minute for it to like build and then produce a Docker image. While this is building, I'm gonna actually I don't want to switch tab. It takes some time to switch between deck and the screen share. So let this go through. So what really happens is as soon as this Docker image is produced, we will register onto our Docker registry and also onto Artifactory as a Maven artifact. And then there is another step in Dataflow which we have to tell Dataflow that this is the coordinate for my application. This is where it's hosted. So the metadata for that application will have to register that. That's a separate step, and that's what this step would do. And once that application is registered, it's now available for use. So you can go manually pull up a shell. You can do stream update, and then update the stream name, and then pass in the property, and then saying the version of the app that you want to update to. It's as simple as that, but we're not going to do that. We're going to automate this. We're going to continuously deploy it. So we have the facility in Dataflow of REST endpoints for the update. The same stream update command that I showed in Shell is backed by a REST API. And in my Concourse pipeline, I have this last step, which actually is going to invoke that REST endpoint. And as soon as this finishes up, and I go back to my Kubernetes log here, you see that V1 version of this transformer is running. When that update is done, we should be seeing a V2 version also pop by. And here we go. It was so quick, it just flashed and went away. So V1 was terminating, V2 is now started. Now if I go back and then like see the payload here, the same payload is just continuing to happen. You're not losing data. It's coming through across all these processors, but the processor in between went through this rolling upgrade lifecycle. And you can see from this point onwards, or the next point onwards, that's the last time we saw the security number without the mask. And the rolling upgrade kicked in, V2 became the primary, V1 got killed off, and now you see the real-time updates happening. So the ordering and the guaranteed message processing is also retained because these applications rely on persistent PubSub like Kafka and RabbitMQ. So when the new application started, it knows where it got cut off because the data is in the same topic or queue, and it trains from where it got cut off successfully. Now, quickly to show what happened to the history of the same stream, Now it has two versions, right? I mean, I have what the old one was deleted, the new one is upgraded. I can very quickly, easily do rollback on the stream. I can pin to a specific version. Imagine you have like 20 revisions on the stream definition. You can go back to any given point in time. So that's another great value that we provide to Dataflow in this native integration. Now to finally confirm what is running in production, I'm going to do the manifest command again, and you can see that now transformer, the XFMR processor is at 008, which is what I did. And then the other two applications remain undisturbed, right? I mean, they are doing its thing and they are happily running, and only this middle portion just went through this dynamic upgrade. So that is the end of that demo. I'm going to switch back to the deck. And quickly to reiterate what we did, what we saw in action. So I did a git commit, build package, went through the test lifecycle, and I have a candidate, and that candidate is now registered on the Docker registry and Maven Artifactory. And then the difference I want to highlight here between continuous delivery and deployment. If I'm super critical company, and I don't want to like automatically do it, I do want to like do some manual testing done, which is where continuous delivery comes in practice. I mean, you have to like validate, and you have to hit the button or some sort of a trigger point to like say push it to production. That's the first workflow. Otherwise, in my case, what I did was continuous deployment. I was fully comfortable, confident about my unit tests and integration tests. I know it's going to work. This is going to solve all customer problems. I'm going to automate it. I'm going to deploy it, and which is what I did, right? So you can see that in action. So this is one way how we see our customers and community doing this types of model on data-centric workloads. Just like goes back to this cloud-native patterns. I mean, this remains as a really critical focus point. If you are onto digital transformation journey, you should have this type of facility, not just for RESTful apps, but also for streaming and batch apps, which is just what we focus on and providing value through Dataflow. So that's the end of that demo. I'm going to quickly jump through a few use cases that we see in the field. So the first one that I have is something that comes up as a common theme, where we have there's a lot of legacy workloads, especially in the systems domain within the enterprise, and also there's a lot of operator workflows where people who are more the database administrators and working alongside with system analysts to build these types of ETL workloads with more in-house solutions, right? Could be ranging from SQL scripts to store procedure to bash scripts. And they all want to like modernize, and they can't like quickly do that. They want to do that in a more incremental way, and that's where we provide these frameworks like Stream and Spring Cloud Tasks, so people can slowly and incrementally move that workload into more cloud-native style architecture, and then the platform comes into play to run them as a runtime. So which we see as a common pattern. And building upon a similar trend, we see like re-platforming legacy data integration workloads. Like we know, like a customer like Bloomberg, for example, they have completely built on top of Spring integration as a product, and they want to like reimagine, modernize that into more cloud-native style architecture. So they are relying on a platform for it, like Kubernetes, and they are wanting to like again port that workload into more a standalone microservices model. Not just to run them as standalone apps, but also reap benefits from other operational aspects of it, so they can auto-scale and be more elastic about their processing power. So that we see as a common trend as well. And the next one that we see is the batch-driven streaming architecture. This comes up so very often from our customers that batch is dying, batch going away, ETL is going away. We see all that chatter in the community too, but we also have that type of business requirements from customers and community, and that still is relevant. But we at the same time we see a more trending move for real-time streaming architectures, and that's where all these new practices, patterns that you come across, such as event storming to event sourcing to CQRS, all that can be applied in practice. There's a really good deep dive talk from a few of our Spring advocates from last Spring 1. As all the recordings are available in Spring Central channel. So highly recommend watch that, so you'll know how you can build these types of architecture with Spring and Spring Setup portfolio projects. And the file ingest, which is what Mark was showing, and the highlight here is not everybody can move away from bare metal private infrastructure to more public cloud. There is that trend that still is happening, but it's not like so aggressive. People are still in a hybrid mode. They still want to retain the sensitive data in their in-house infrastructure and move more public-facing stuff towards public cloud. So that hybrid model is still relevant. So we provide a flexibility in terms of consuming from in-house NFS drive, or you want more public-facing S3 protocol-based like blob storage or something like that. So we provide facility for that too. So you have this options to like consume files from different things, different, more hybrid setups. You have different types of volume mounts, and we provide facility for that. And of course, like goes without saying, when you're running in a container orchestration runtime like Cloud Foundry, you have the option to like, scale these compute powers. So as the file sizes of the traffic grows, you have the facility to like go up and down. So that's a really good value add for some of the folks who are migrating over from this types of more legacy infrastructure to modern workload. And then the next I have is stateful stream processing, which is where I demonstrated some Kafka stream specific use case. We see a lot of chatter from community in our Gitter channel on this area. There's a lot of contributions from community too. Thank you for that. Not just from a simple moving window or time averaging kind of use cases, but also more complex ones where you can represent data as rows and tables and represent them as a K table. And you have API to like feed on those tables, do some interesting thing, and project the outcome as API, so your dashboards can feed from that. Likewise, interactive queries. So they are all like really, trending solutions out there in the Confluent Kafka Stream, Kafka world. So we piggyback on it, and we provide more automation, more reduce all the boilerplate a developer have to go through in terms of building that type of stateful apps. And the scheduled batch jobs, again, we saw that in action. So this is another trending theme that we see from our users. And so some of the use cases that we see are around the data migration to file movement to predictive model training. I mean, these are timed events. Not everything has to be real time. Not everything has to run all the time. They are like schedule driven, which is totally a relevant business requirement, and we provide really a native integration to facilitate the scheduling of batch jobs. And the last one I have is about real-time predictive analytics, which goes back into the machine learning theme that I discussed early on. They provide a variety of endpoints like TensorFlow to PMML to Python. There's a lot of data science personas who want to build and operationalize predictive models, and imagine this continuous delivery like model. So you have a model today, but then there's data incoming all the time. You're learning all the time. You have a new training model, new training data set. You want to predict, produce a newer model based on all this newer information. And how do you continuously deploy that type of model? So that's where we provide all this continuous delivery model. But at the same time, we see a lot of trending, users wanting to embrace and adopt TensorFlow like Toolkit. There's a really detailed blog in the attachment sections on what we do. And in this GIF that you see in the slide is a real-time human pose estimation. Think of use cases where autonomous car and then pedestrians and cyclists and estimating poses and then deciding, how to maintain distance and braking aspects of it. So there's a lot of applications of it, and then the blog walks through some of the use cases too. So we're really excited about it. Try it out, give us feedback. We're constantly evolving on this space. And yeah, that dovetails into the last slide. This is about a quick highlight into what we are doing currently and the next steps in terms of roadmap. So all these apps that we discussed so far, like data integration apps to source processors and sync, we are working on an initiative where we are like reimagining how Spring Cloud Stream provides this binding framework onto different brokers. But then the business logic will be written with Spring Cloud Function as programming model. So ultimately, developers would have to like implement Java util functions interface, whether it's a supplier function or a consumer, which represents source, processor, and sync respectively. So you are just writing simple functions, and that becomes a reusable artifact, reusable catalog. So you can chain different functions together. It has pros and cons to it, but imagine like you have like series of small steps, but you want to compose into one app and run them as simple app. So you can, test that in isolation in a more a concrete way, and then orchestrate them with upstream and downstream apps. So we are putting our thoughts, and then we are investing on that initiative. So your source and processors can be combined into one app or things like that. So there's also a deep dive topic planned for Spring 1. So please just check it out. And the second one I have is Kafka Streams like use case, which is always like multiple input topics. You want to like consume events from multiple different Kafka topics. You're doing some aggregate and then producing and branching out this outcome onto multiple downstream consumers. Here we are making Dataflow more flexible to adapt to that type of model. Right now, Dataflow is strict about like single channel, both incoming and outgoing. But imagine what type of use cases that you can build when the DSL and the UI represents this type of flexible orchestration. So that's something that we are really excited about. It's coming out in 1.7. And the third one I have is audit trail, which gets into who did what and when. How do we track who deployed the stream and destroyed the stream? Some auditability and traceability aspect of it, which we get as feedback from the users. So we are adding that in 1.7 as well. The fourth one is task launch and rate limiting. You saw that in action from Mark's demonstration. So you can control and sort of throttle how much tasks you want to launch at a given point concurrently. There's a facility to do that. That's coming up in 1.7 as well. In the longer term, right now Spring Cloud Dataflow 1.x line is based on Spring Boot 1.x. But now we are venturing into Spring Boot 2.0 and may bring the newer Java version compatibility into Dataflow itself. Just to note that all the Spring Cloud Stream and Spring Cloud Task frameworks are already compatible with Spring Boot 2.0 and the newer versions of Java. All the apps that we provide are already 2.0. But this is what I'm referring to here is Spring Cloud Dataflow itself. That boot application itself can be now orchestrated on modern, newer Java runtimes. So yeah, I mean, I think that's the last slide. I think we are top of the hour here.
So we look at some questions and answers, Sabby.
Yep.
Cool. Sorry, 1 second. My screen just chose that moment in particular to blank out. Okay, so the first question from the audience is about the Dataflow scheduler. It seems like it's also possible for an external scheduler to launch tasks in Dataflow via the REST API. This would need to be secured, but it seems like a good alternative to take advantage of advanced scheduling features. Is this under consideration, or is it currently supported?
I'll take that. Maybe Mark, you can.
All right, you're ahead. Go ahead, Sam. Sure.
Yeah. So
no problem.
You're right. There is a REST API to launch a task, and we provide authentication mechanism, traditional and OAuth mechanism, and they are protected. So if you have a scheduling system like Control M and among other things, it comes up kind of very common from our customers. So if you have those types of schedulers, and if that has a webhook facility, you can schedule against the webhooks, and that'll be mapped to our REST APIs, and that the REST API would represent the task definition, so you can schedule and launch the jobs that way. But also the advanced scheduling features itself is something that we rely on the platform and the platform what it provides too. So in Cloud Foundry, at least, we have PCF scheduler that has its own roadmap in terms of newer advanced features. As far as that is available, if you are running batch jobs in Cloud Foundry, you would be able to take advantage of it. Likewise, on external schedulers too, you would take advantage of what that tooling is providing. We are not like building those types of ability in Dataflow itself, where we are like simply delegating it to the products which are really good at those types of things. So, Mark, I don't know if you have anything else to add to it.
No, not really.
Yeah, no,
right, cool.
Sounds like you nailed it. Yeah. Cool, folks. So if you have other questions, now is a great time to enter them in. While you're thinking about that, let me give you a few other things to think about. You should be seeing a banner across the top of your user interface right now talking about Spring One platform. That is where you can learn, as Sabby and Mark mentioned earlier, we even have recordings from last year that are still quite relevant and fantastic. But we'll be recording all of them this year if you can't make it. But we also have Spring One tour going around to many different cities within the United States. But Spring One platform is still the best place where you're going to hear people like Mark, and many others, customers alike, talk about how they're using Spring Cloud Dataflow, Spring Cloud Stream, Spring Cloud Task, and basically handling data-intensive applications. So that is in September in Washington, D.C., and you're welcome to use my personal code for an extra $200 off of your ticket. If you can grab it right from the user interface anytime here. Also, Mark and Sabby have been kind enough to give us a number of follow-up links. If you go to the attachments and links section of your user interface, you'll find a number of helpful resources there, as well as there's a blog that covers the highlights of the 1.6 release that you can share with your colleagues. This presentation will also be available very likely within 1 hour's time on the same URL that you used to register for the event. So if you have an email in your inbox, saying thanks for registering, that has the URL to the landing page in it, that is where the recording will be published, and all of these attachments will be published there as well. So that's a great resource to share with your colleagues and can give you what you need very quickly if you want to do in a presentation to your colleagues on, to do the lunch and learn presentation for your colleagues on things you've learned this week. Also, there's a number of other good links in there for GitHub repositories, excuse me, and some of the sample applications. If you're looking to get a hold of the actual software, you can go to the project page and you can consume Spring Cloud Dataflow for the various platforms that it supports, like Cloud Foundry, Kubernetes, and local development by grabbing either a Helm chart or a Docker image or a jar file as appropriate. But unlike most other Spring pieces of software, Spring Cloud Dataflow is not just, oh, thank you, perfect, Sabby, yes, thanks so much. Spring Cloud Dataflow is also a server, as I'm sure you've noticed. Mark and Sabby have been starting server processes throughout this whole demonstration. So it's not just an embeddable jar file library that you embed in your application like so many other Spring projects. This also is a distributed runtime based on Spring Boot, Cloud Foundry, Kubernetes, etc. So that's how to get a hold of the actual software. Let's see if there's any other questions that have come in. No, not yet. I guess maybe just to kind of finish things off and tie it up, Mark or Sabby, would you tell people what's the best way to get started if they want to dig in and start playing with this stuff?
Yeah, I can take it. Well, we support 3 platforms, and so pick your poison. The easiest one, I think, generally speaking, is the local platform. So when you're on the web page there, you can just go to each individual project. Right now, what's being shown is the main one for the local server. But then if you want to go to Cloud Foundry or Kubernetes, you would go there, and there are a variety of ways, but the easiest is to use the Docker images that we provide, so you can literally just spin the whole thing up in Docker, because there's a few moving parts, right? You need a database, and you need 2 servers, the one that does the rolling updates, as well as the main Dataflow server. And I think as Sabby, or maybe you, Peter, just mentioned, we have a Helm chart. So if you're a Kubernetes fan, then that's also super easy. And then on the Cloud Foundry side, there is a tile that's available. So you can install the tile, and then that is the easiest way for that platform.
Mark, for our listeners that might not know what a tile is or what a tile does for you, maybe could you talk about that for a moment? Because you actually just set it up, right? You were just showing all the databases and other services that you'd have to set up yourself.
Right, yes. So tile is a way you deliver functionality, I guess, services onto Cloud Foundry. It's one of the core abstractions or services. And so often that's middleware, things like Rabbit and databases. But in our case, it's the Dataflow server itself. So usually an operator of the Cloud Foundry platform will download this package and install it. So it's sort of the apt-get of Pivotal Cloud Foundry.
That's a great way to explain it. I've never, haven't heard it put quite that way before. That's cool.
That's the way I view it.
I like it. Well, yeah.
There's a more polished answer from the team who actually.
No, I love it. I love it. Yeah, I mean, it's setting up all the underlying databases and infrastructure and messaging queues that you need without you having to do it yourself. So you're out of the business of provisioning. Pretty cool stuff for Cloud Foundry users. Okay, great. All right, folks. Well, if you wouldn't mind taking a moment, drop off some votes on what you'd like to hear from us in the future, and maybe even take a moment and give Sabby and Mark some feedback, and just rate the content that you saw here today. That would be wonderful. Also, there are a number of upcoming webinars that I'd love to draw your attention to. We're on in September 5th. We're going to talk about how to migrate applications over to Pivotal Cloud Foundry. On September 6th, James Weaver will be joining us for a demonstration on Spring Webflux and Project Reactor. On the 13th, we're going to have an analyst webinar on how platforms and application visibility can drive business outcomes. Excuse me, actually, I think that one's Dynatrace, pardon me. Then Jakob Pilamon, one of our developer evangelists for the Spring team, is going to be talking about event-driven architecture traps. So if you were here today talking about streaming and listening to Spring Cloud Dataflow, I strongly recommend you check out the 19th webinar for Jakob, event-driven architecture traps. And again, you can just find all that at content.pivotal.io/webinars. So with that, I think, oh, thanks, Amy. Perfect. Yes, fantastic. Anything, Mark, Sabby, you'd like to say before we close out the session?
Thanks for everyone taking their time today. Appreciate it.
Yeah, thank you for joining. Yeah, please be social about it. Reach out to us, Stack Overflow, Gitter, and other means. We're always there. So if you have any feedback, questions, don't hesitate. Let us know.
Thanks, everyone, for your time and attention today. Hope to see you at a future webinar. Enjoy your day. Bye-bye.